Good afternoon and welcome to this video for the 2020 Level 1 Mechanics video for Level 1 Science. So if we look at question 1, so Felix Baumgartner is famous for jumping from a height of 40 kilometers above the Earth. He fell for over 240 seconds before opening his parachute. Below is a graph of his speed versus time for the first 60 seconds of his jump. So that's our speed over time graph. Question A. Describe Felix's motion in section A and C of this graph. So in section A, we can clearly see that there is a constant increase in the speed. And if there's a constant increase in the speed, then this means that there's a constant acceleration in the Felix is having a constant acceleration when he's falling down. So section A is describing constant acceleration. So we can write that one down. For section C of the graph, we see that he has reached a point where his speed is constant at 350 meters per second. And after about 40 seconds, he's going to have a constant speed. So we just say this is a constant speed. Alright, so state the maximum speed reached by Felix. If we go back to our graph, we can clearly see the maximum speed reached is 350 meters per second. So we just write that one down. So 350 meters per second is the maximum speed. So that's 350. Use the graph to calculate Felix's acceleration in the first 30 seconds. So the acceleration of an object is basically its change in velocity over the change in time. So we can say that the acceleration is the change in velocity over the change in time. In other words, it's going to be the gradient of this line here because it is a speed over time graph. So as we can see here, we can see that Felix is starting at 0 meters per second and he reaches a speed of 300 meters per second in a time of 30 seconds. So the change in speed is 300 and the change in time is 30. So acceleration is 300 over 30, which equals to 10 meters per second. Oh, sorry, per second squared. Apologize. Okay. So that's our answer for that question. So question D, use the graph to calculate how far Felix fell in the first 30 seconds. So in this case, we're just going to be calculating the area under the graph since we know that D equals to V times of T. Since D equals to V times of T, we can just say that the velocity at any moment times the time is going to be the area underneath the graph, and that's going to be the distance traveled by Felix. So in the first 30 seconds, we're going to see a triangle here. So we're just going to calculate the area of the triangle. So we can say that distance traveled equals the area under the graph. So distance traveled equals to the area under the graph. So area equals to half base times height. Area equals to half times of 30 times of 300. Alright, so 300. Alright, and that gives us a distance of 4,500 meters. So distance equals to 4,500 meters. Question E, the graph is repeated from page 2. Draw and label the arrows on the diagram below to show the size and the direction of the vertical forces acting on Felix in section A and section C of the graph. So when we first look at section A, we calculated that the acceleration of Felix was 10 meters per second downwards. Since that is actually the acceleration of gravity towards the Earth, so that's actually the acceleration of the gravity towards the Earth, and therefore the acceleration of Felix is the same. That means at section A, there's actually no vertically upwards forces acting on Felix, and it's only the force of gravity acting on Felix on section A, because only gravity is pulling Felix down, and there's no vertical forces that's pulling him up. Therefore, the net result is that he has an acceleration of 10 meters per second downwards. So right now the pictures are blacked out because of copyright, so I just draw this object here that represents Felix. At section A, he's just going to have this acceleration downwards. It's just going to be F of G. Okay, so that's our vertical forces. There are no vertical forces acting upwards since there is he is accelerating at the same rate of acceleration of gravity. At section C, he now has a 0 meters per second acceleration. That means all the forces are balanced since at a constant speed there is no net forces, meaning there's no net acceleration. Therefore, the air resistance created is equal to the force of gravity acting downwards, and this 350 meters per second is what Felix has reached his terminal velocity. So if I draws Felix in section C, he is still going to have Fg acting downwards. That hasn't changed. But we also now have a force of air resistance. We can call this F of air. So the air resistance is upwards in an equal and opposite direction. So there's no overall net forces. So that's our section A and section C. So now we need to explain the motion in section A and section C by comparing the vertical forces acting on Felix. So we just basically need to cover the points I just mentioned. So we can say in section A, Felix accelerates at the same so we can say since we can say this means there are no and the only force acting on Felix is the force of gravity, so his weight force basically. So the only force that's acting is the weight force. Okay, so that's section A. So therefore Felix has a constant acceleration downwards. Okay, so that's our section A. In section C, he is traveling at a constant speed. So meaning there is no external unbalanced forces. And hence no unbalanced, hence no acceleration, sorry. So you can link this one to F net equals to 0 newtons. And we can say this is when the air resistance developed is in equal but opposite directions of the Fg. To cause no net force. This means no acceleration. So you can say this is the maximum speed, also known as the terminal velocity. Alright, and that's all of the points we really need to link here. So we just need to talk about section A and section C. And in terms of this should be an excellence level question. So if you can talk about both section A and section C and linking it to the forces acting on Felix, that should be an excellence grade. To get a merit, if you can just link maybe like one of the sections in a complete discussion, you could get a merit. For an achieve, you can just say like a bit of bullet points here and there. For example, for A, you can just say just only the force of gravity acting, just something like some short sentences, short statements might get you an achieved. For question E, this is probably just an achieve question. For question D, this is probably a merit level question. And if you recognize that the distance traveled is the area underneath the graph, that could get you an achieved. Question C is definitely an achieved question. Question A and B are definitely just achieved level. Question 2. Each year, firefighters run up to the Sky Tower. Lindley is preparing for this event by running up the stairs in her building. Each day she climbs to a height of 25 meters. Below is data from 2 of these days. So question A is compare the work done and power produced by Lindley on each of these days. In your answer, you should calculate the work done on each day, calculate the power used on each day. So as we can see here, on each of these days, the mass of Lindley and her equipment stay the same, as well as the height climbed. Since the work done is basically the amount of chemical potential energy in Lindley that is transformed into gravitational potential energy, the gravitational potential energy only depends on the mass, the height, and the height climb, basically. So in this case, the amount of work done, so the amount of chemical potential energy transferred into gravitational potential energy, because work is transferring energy into different forms. So the work done is basically just equal to a gravitational potential energy gained. Since Lindley is gaining the same amount of gravitational potential energy, that means the work she does every day is the same. However, as you can see here, on day 1, she takes 50 seconds to run up the tower, and for day 2, she takes only 30 seconds. So we know that the power is basically the amount of work done over time, so that's the rate of work being done. So as you can see here, if we have the same work being done over less time, this means that she needs to produce more power. For day 1, she produces less power since the same amount of work is done in more time. So for this question, we can say that okay, so in this case, it is chemical potential energy. So you can say it's transferred to gravitational potential energy. You can say since EP equals to mgh and the height climbed and mass stays the same, so you can say she's doing the exact same work she's doing the same work every day. So you can see the power is the rate of work being done on day 2. She does the same work in less time. Same work in less time. So you can say P equals to work over time. So you can say that therefore she needs more power on day 2. So you can say calculations now. So calculations are very straightforward here. So work equals to force times distance, but in this case, it's basically the amount of gravitational potential energy gained. So therefore, EP equals to mgh, which equals to 60. Was it 60? No, it was 80. My bad. 80. 80 times 25 times g. Oh no, using 10. Sorry, I keep forgetting. Okay, times 10. Okay. So 80 times 25 times 10. So that's 20,000 joules of work. It's 20,000 joules. So this is for day 1. And you can say P equals to work over time, which equals to 20,000 joules of work done over the total time of 30 seconds. No, 50 seconds for day 1. Day 1, 50. So therefore, this will give us an answer of 400 watts. For day 2, we can say that EP is the same, which is 80 times 25 times 10, which equals to 20,000 joules. And you can say power equals to work over time, which equals to 20,000 over 30. And that gives us an answer of 666.67 watts. So as you can see here, the power on work on day 2 is greater than the power on day 1, but on both days she does the same amount of work. So this is actually a very comprehensive question. This should be an excellence level question, okay, for both the calculations and the explanation. And personally, I think the explanation itself should be worth a merit, and the calculations itself should be achieved, and both added together should be an excellence. Question B. Lindley looks into the stairwell and her helmet falls off. The helmet falls between the stairs without touching them. She estimates the helmet will hit the ground at 20 meters per second. Well, wonder how she estimates that, but I'm not going to ask any questions. So using conservation of energy and assuming no other external factors. Okay, so no external factors, no other, so that's basically no other unbalanced forces. Okay, so we can say the mass of the helmet is 1.5 kilograms. So basically we know that at the height that Lindley drops the helmet's going to have a certain amount of gravitational potential energy. When she drops the helmet, some of this gravitational potential energy is going to be lost and transferred into a kinetic energy. When the helmet makes contact with the ground, it has no more gravitational potential energy relative to the ground, but therefore that means all of the gravitational potential energy it had has been transferred into kinetic energy. In real life, we know that this is not the case because we know there's air resistance, and this friction causes heat and sound to be lost as energy. So therefore, not all of the gravitational potential energy is transferred into kinetic energy. But in this case, we are assuming no other external factors, meaning that we're ignoring friction. So we can say, since friction ignored, we can say that EP equals to EK. We know that EK is given by half mv squared. So therefore, EK equals to half of 1.5 times 20 squared. So 20 squared times 1.5. So this gives us an EK of 300 joules. And that's EK equals to EP, EP equals to mgh. So therefore 300 equals to 1.5 times 9.81 times the height. So 300 divided by 1. Oh, why am I using 9.81 again? Sorry. Getting too used to doing level 3. Okay. So divided by 1.5 divided by 10. So height equals to 20 meters. And we need to describe from which form the kinetic energy has transformed. So energy transforms from energy is Alright, that's all we need for this question. Okay, this question should just be a merit level question. Okay, a merit for both of the explanation and for the calculation. Any one of them should get you an achieved. Question C. Explain why the helmet will not reach a speed of 20 meters per second. Okay, so for this one, we can say that, as I was just explaining, the friction, so we can say in real life, so friction acting on the helmet, this causes heat and sound energy to be produced. this means that not all the EP is converted into EK, as some energy is lost. You can say the decrease in kinetic energy directly affects the velocity since the mass is the same. So we say EK is proportional to B squared, hence the helmet does not reach 20 meters per second. That's our final answer for that question. Okay, this is just another very standard merit level question to explain that some of the energy is lost to heat and sound. So, question 3. NASA has revealed a possible vehicle to travel over the Martian surface. Mars is a very dusty planet with a much lower gravity, well, it's taking gravitational field strength, okay? So, gravitational field strength on Mars is 3.7 units per kilogram. On Earth, it is 10 units per kilogram. Define mass and weight. Okay, so basically the differences. So, we can say that mass is the amount of matter in an object. This stays the same. Well, this usually stays roughly the same, so we can say this stays the same regardless of whether we are on Mars or on Earth. Weight is the amount of force experience due to the gravitational field. So this is actually the reaction force that's felt by the surface. Okay, so weight, reaction force felt by surface. You can say this can change at Mars on Earth. This changes on Mars/Earth as weight equals to, not weight, just say F equals to mg. Okay. Explain what 10 units per kilograms means. This means that 10 units per kilograms means that for each kilogram of mass, a 10 Newton so very basic explanations there. So for each kilogram of mass, for each 1 kilogram of mass, a 10 Newton weight force is experienced. Okay, so that's what 10 units per kilogram means. Calculate the weight force of the Mars vehicle when it is on Earth and when it is on Mars. The mass of the Mars vehicle is 2,500 kilograms, so the weight on Earth is F equals to mg, which equals to 2,500 times 10. That equals to 25,000 newtons. For Mars, F equals to mg, 2,500 times 3.7. That gives us a force of 9,250 newtons. There are 6 wheels on this vehicle with a surface area of 0.25 meters squared per wheel. Calculate the total pressure this vehicle will exert on the Earth. So in this case, we have a surface area of 0.25 meters squared per wheel. So we know that the pressure is the force over the contact area, so F over area is the pressure. And we also know that on Earth we have the wheels, which is the vehicle, which is 25,000 newtons. So we can say weight is 25,000 newtons. We have 6 wheels, and if we assume that all the weight is distributed equally on these wheels, we can assume all weight equally distributed. So weight on one wheel will be equal to 25,000 over 6, which gives us 4,167 newtons. So therefore, we can use P equals to F over A, and we can use 4167 over 0.25. That's for one wheel, so we can say this is. So this gives us 16,666.66 newtons per meter. Newtons per meter, you use pascals for that one, so PA. Okay. So in this case, okay, that's the amount of pressure for one wheel. So if we multiply by 6, we should get the total pressure. Multiplying by 6, a total equals to 6P, which equals to 16,666.66 multiplied by 6, which equals to 100,000 pascals. That's our final answer for this question. That's the questions here. That should just be achieved and achieved. Defining mass and weight, that should just be achieved, and that's achieved as well. It's a very simple achieved question there. So, the Mars vehicle is planted on similar soils on Earth and Mars. Explain why the Mars vehicle will sink to different depths on each planet. Okay, so since the soil is the same, so we can assume that all the physical quantities of that soil are similar. So we can say on Mars, so the wave force of the vehicle is less on Mars. So this means the total force exerted on the surface of the soil is less on Mars. You can say since the area of the wheel stays the same, so say P equals to F over A. So we say the total pressure exerted on Mars is less than on Earth. Since the depth sunk is determined by the amount of pressure, the vehicle sinks less on Mars. And hence will sink deeper on Earth. So that's our explanation. In terms of our calculations, we say that the total pressure on Earth that was equal to 100,000 pascals. On Mars, we can say that F equals to 3.7 times 2,500 it was. That was 9,250 newtons. So we say total pressure equals to F over A. Which is, we can just use the same methods. We say this divided by 6 is the amount on one wheel. So divided by 6 is equals to 1,566 newtons. P equals to 1541.66 over 4. Over 0.25. So this gives us 6,166.67 pascals. And we need to multiply by 6. So total equals to 6,166.67 times 6, which equals to 37,000 pascals. So as you can see here, 37,000 is much less than 100,000 pascals. Hence, We don't really need to say anything else, okay? So that's our final answer for this question. Okay, so our explanation and our calculations, that will get us an excellence grade. To get a merit, you probably need to have the explanation. That should be enough for a merit. To get an achieved, if you can calculate the pressure on Mars, that should be an achieved. Alright, so thank you for watching this video. I hope you enjoyed, and I hope